Hello everyone, my name is Mohan BALAJI from RMD Engineering College, Department of Artificial Intelligence and Machine Learning. Today I am here to present our project on predicting hospital readmission using advanced machine learning techniques to improve healthcare outcomes. We are Team Supernexus, team number 5 from RMD Engineering College. Our team consists of 5 dedicated members, myself Mohan Balaji, Monish, Tarun Raj, Vishal and FAIZUR RAHMAN. With guidance from our faculty mentor Mr. Satish Kumar sir and support from industry mentors Mr. Dinesh Jackson sir and Mr. Karthikeyan sir. We are working together to address healthcare challenges using artificial intelligence and machine learning. Unplanned hospital readmissions are the major challenges for healthcare systems. They increase cost, put pressure on resources, and interrupt patient recovery. Traditional prediction models often rely on a set of features and manual analysis, which limit their accuracy. There is a need for better solutions that can use more detailed patient information to predict readmission risk, and healthcare providers take yearly actions to improve patient care. The existing system, hospitals usually estimate a patient's risk of admission using scoring methods like LACE index and hospital score. These tools are easy to use but typically places a patient into both risk categories. They often miss important personal details, which can lead to many false predictions because this score does not consider full medical history or lifestyle factors. They are limited in helping ethical providers making the best care decision. Our proposed system uses a combination of machine learning methods like random forest, gradient boosting, and XGBoost. These advanced algorithms work together to improve how well we can identify a patient at a risk of readmission. This is our system architecture of our project. At the core, our user or faculty will interact with our system through the front end, which is deployed on Azure Static Web App. For secure login and authentication, we have integrated Firebase authentication system. The front end communicates with the backend service hosted on Azure App Service. This backend service are powered by Fast API running on Linux plant with Python version of 3.12, and they can handle both the application logic and the deployed machine learning models. For monitoring and security, we have used Azure Application Insight to track the performance and the error, and Azure Key Vaults to securely store sensitive credentials and keys. Our deployment process follows a CI/CD pipeline. The development team collaborates in the hospital readmission prediction repository, where different branches are staging front-end deployment and back-end deployment. Once the changes are committed, they are automatically pushed to the respective tab branches and get updated without any downtime. Altogether, this architecture ensures a scalable, secure, and automated system for hospital readmission prediction. This is our hospital readmission prediction system. Here you can see the landing page of our project. Our project begins with the overview and the problem statement, which explains the challenges we aim to address. For training, we have used a Kaggle dataset, and our machine learning task falls on the category of classification. Next, we present the architecture diagram of our application along with the complete ML pipeline. This includes the data pipeline, model training, and the deployment process. We have also highlighted our learning outcomes, what we understood from the problem statement, the approach we followed, the classification techniques we applied. For evaluation, we have used matrices such as accuracy, ROC, and F1 score. Our results were accuracy around 70%, ROC score under 86%, and F1 score around 81%. The domain of our work is life science, and our data set was sourced from Kaggle. It consists of around 25,000 patients record with 17 clinical features. Our approach was as follows. First, data pre-processing, model development, model interoperability, web application development, deployment on the cloud using Microsoft Azure with a CI/CD pipeline for continuous integration and delivery. We also faced some technical challenges such as class imbalance, feature engineering. For our tech stack, we have used for front end, we have used React.js. For styling, we have used Tailwind CSS. And authentication, we have used Firebase Cloud Services. In the backend, we have used Python with Fast API, machine learning library, Scikit-learn, and model explainability, Sharp library. And the cloud services we have used is Azure Static Apps for frontend and Azure App Service for backend deployment and GitHub for remote repository. We have also included a collaboration page on our website. Our team contributors for the Hospital Readmission Prediction System are myself, Mohan Balaji, TARUN, MONISH, VISHAL, and FAIZUR RAHMAN. Throughout the development process, we have used Jira to systematically track our work progress. Our 5 team members managed 38 work items over 8 days, organizing everything into focused sprints with daily stand-up meetings. The agile approach ensured transparency, accountability, and efficient delivery of our system. Here, we have included a screenshot of our Jira work progress overview. From August 20 to August 2026, we have completed the first 2 sprints over 5 days, accomplishing a total of 22 work items. During sprint 1, we have discussed the problem statement and designed the user interface and designed the architecture system. In sprint 2, we have completed the ML model development and implemented the authentication system and built dashboard UI components and integrated the basic API and core functionality. In final sprint from August 27 to 29, we have conducted model evaluation, integrating the ML model into the backend for front-end usage, implemented the CI/CD pipeline for continuous development and continuous delivery, and we have also tested the user interface and hosted it on Azure Cloud Platform and finalized the project documentation. For collaboration, we have used Jira for project management and work tracking, and GitHub for version control and code collaboration, Google Meet for daily stand-ups and communication, Google Docs for documenting and knowledge sharing. This systematic approach allowed our team to efficiently deliver a high quality and fully functional hospital readmission prediction system. Next, a user can create a new account using the sign up option. Since I already have an account, I will sign in with my credentials. User can also reset their password anytime using the forgot password link. After logged in, the user is redirected to the dashboard page. This page is protected route, meaning only authorized user who logged in can access it. Unauthorized users cannot view this page. On the dashboard, there are 2 types of input formats available for predicting hospital readmission. The first one is bulk predictions by uploading a CSV or Excel file. The second one, input type is single prediction by clicking on a manual entry option on the top right. Additionally, if you just want to test whether the prediction system is working, you can use random sample button. This will send the sample patient data to the backend and return the prediction. When a prediction is made, the result includes serial number of the patient, risk category, whether high risk or low risk, and the probability and the reason why the patient is categorized as high or low risk. For example, in this case, a patient is predicted as high risk because a total number of medical procedures increased by the probability of 0.012. Procedure interaction contributed significantly to the prediction. A longer hospital stay also raised the probability. Meanwhile, some factors slightly reduced the risk, but the above feature had the stronger influence. We also provide an interactive graph that shows feature contribution. This chart explains Which feature contribute most to the prediction of high or low risk in the clear and visual manner. We also provided an interactive graph that shows feature contributions. This chart explains which feature contributed to the predictions of high or low risk. Now, let's look at the bulk predictions. I will upload a sample CSV file containing 7 patient records. The system processes each patient one by one through the front end and the back end. Once the process is complete, it returns the predictions. For example, patient 1 might be classified as high risk, patient 2 as low risk, and so on, based on the probabilities. If you want to analyze a specific patient in detail, you can simply click on their records to view the feature contribution graph in an interactive format. User can also export the prediction result using the Export CSV button. This allows all the prediction data to be downloaded in the Excel format for future reference. Azure Cloud Integration Demo. For this project, we have maintained a resource group in Azure called Hospital Readmission RG. This resource group contains both our static web app for the front end and the app service web app for the back end, all managed under a single group. Here you can see the app service and static web app resources. The front end is hosted on Azure Static Web App, while the backend is hosted on app service. The backend has dedicated URL which can use to get response from our APIs. To test our backend, we use Postman. For example, if we hit /example endpoint, we have received the predictions along with the feature contribution explanation. We set the request type to the post, provide the data in a raw JSON format, and send the request. The backend responds with a prediction value, which include sharp values. These sharp values are later used to generate graphs and explain why a particular prediction was made. Now, let's look at the GitHub CI/CD pipeline of our project. We have maintained a GitHub repository with separate branches for deployment. The branch Azure Backend Deploy is used for backend deployment. Azure Deploy branch is used for front-end deployment. Test branch is used for testing the application before the deployment. For the front end, Azure Deploy branch, we have configured the GitHub action workflows. If any changes are pushed to this branch, it triggers the YAML workflows and automatically deploys the updated front end to the static web app. The reason we created a separate branch for the front end and the back end is to avoid unnecessary redeployments. If the front end and back end were in the same workflow, even a small front-end change would unnecessarily trigger a back-end redeployment. By separating them, changes in Azure deploy only trigger front-end deployment. Changes in Azure back-end deploy only trigger the back-end deployment. This ensures clean, efficient, and optimized CI/CD process for both our front-end and back-end services. Thank you.